Hello and Namaste. In continuation with the Z transform, we are dealing here with the different properties or a standard function, Z transform of a standard function. Out of this today's session, we'll be having Z transform of 1 by n, Z transform of 1 upon n plus 1, Z transform of a to the power n upon n factorial, and Z transform of 1 upon n factorial. So moving ahead with this, we'll be having this particular Z transform of 1 by n. If you observe here, Z transform of 1 by n, according to the definition, it gives us summation 1 by n z to the power minus n is moving from 1 to infinity. If we'll just put the values of n is equals to 1, 2, 3, 4, so on, we'll be getting this. So this is the first term, n equals to 1, n equals to 2, n equals to 3, and so on. So we'll be getting this type of series, and if you'll observe here, this series is nothing but the Maclaurin series or the expansion of log of 1 minus x series. So log of 1 minus x is coming out to be minus x square by 2 minus x cube upon 3 and so on. But if you observe in this particular case, we are having all the terms, all of them are positive terms. And what is the value of x in this case is? X in this case is 1 upon z. So it is nothing but x plus 1 by 2 times x square plus 1 by 3 times x cube and so on. But if we wanted to have this is nothing but the negative sign. So we are taking the all negative sign, and we can write down this particular term as this one. That is nothing but minus log of 1 minus 1 upon 1 minus 1 by z. So this is what is the series what we are going to get it, or the Z transform of this particular function, Z transform of 1 by n. Again, if you observe the ROC in this case, we can have the ROC as mod of, as we have taken this as a series, and this series is applicable only if mod of this 1 by z is less than 1. That is, mod of z is greater than 1 as the ROC, and we can just simplify this particular function, absorbing this minus sign inside the log. We can have it log of z upon z minus 1 as the Z transform of 1 by n. Similarly, Z transform of 1 upon n plus 1 is nothing but the same way what we have done it, putting the value of n is equals to 0, 1, 2 and so on. Now again you can check one very important thing over here is, here in this case we have started the summation with n equals to 1, because if you observe we have got the function 1 upon n. If we are starting this particular series or particular summation from 0, we are going to get it 1 upon 0, which is going to the infinity. Similarly, for this particular summation needs to start from n equals to 0, because we have to start. So if you observe here, this is going to be 1 by 1. But if we'll start this particular summation with minus of 1, I am going to get this as 1 upon 0. This is again going to be infinity. So again, this second time summation is going to start with n equals to 0 to infinity. So again, putting the values of n equals to 0, n equals to 2, n equals to 1, 2, 3, 4, so on, we are going to get this type of series. Again, rearranging the term, rearranging this particular series over here, we can easily check it here that this we are multiplying by z and z over here, so we'll be getting something like this. So we have what we have done here in this series, we have done it multiply divide by z over here. So we got it as this particular z is here, this one, and this z is gone inside the series with each and every term. Why we have done that? Because we wanted to go and use this particular type of series. So this is nothing but we can have it as, this is minus of log of 1 minus 1 by z as the expansion what we have seen it here, into z will be here. That is what, after arranging the terms, taking this minus sign, absorbing the minus sign inside the bracket, inside the log, we will be getting z into log of z upon z minus 1 as the Z transform of 1 upon n plus 1. Now moving ahead with this particular function, that is Z transform of a to the power n upon n factorial, again with the definition. So this is coming out to be 0 factorial, because the function here, again the question might come that we have got here n factorial, why have you started with a 0? Because 0 factorial is equals to 1. That means what, the lowest value is not going to be 0. That's the reason we have started the summation with 0, n equals to 0 to infinity. Again, this is same as that of, so it's z to the power minus n. We are arranging this term and we have made this as a by z to the power n into 1 upon n factorial. We'll be having this type of series. Again, if you'll observe, e to the power x is the expansion, or a Maclaurin series or a standard expansion as 1 plus x square upon 2 factorial and so on. We will observe this particular series and we can have this as e to the power a by z, because in the case here is, this is nothing but the value of x. So e to the power a by z is the z transform of a to the power n upon n factorial. Moving ahead, if we wanted to have this 1 upon n factorial, we can use this particular result by putting the value of a is equals to 1. If we put a equals to 1 in this particular z transform, we'll be getting z transform of 1 upon n factorial is nothing but, again putting the same a equals to 1 in this here, so we'll be getting e to the power 1 by z as the value for this particular value. Or particular z transform of 1 upon n factorial. So these are the two small this standard formulas I have taken it here for this particular session. Thank you. Happy learning.